Hello friends, welcome to Physics in 20 minutes. In this video we are going to continue with the projectile motion which we had started already in the last video. In this video we are going to talk about the range of a projectile, height of a projectile, time of flight, and we are going to look at some examples. You can revisit video number 22 as a prerequisite. Let's look at range first. If you have our coordinate system, you have a projectile which is projected at an initial velocity v0 and angle alpha 0. So you can see that in this projection the projectile will come at the same level of y is equal to 0 where it was projected. The horizontal distance that it covers before coming to the same level is referred as the range of the projectile, while the maximum height that it achieves from the x-axis is called height of the projectile. The total time it takes to cover the range is called time of flight. So let us derive them one by one. Firstly, the range of projectile. Range of projectile is the horizontal distance covered when it reaches at the same vertical level at which it is launched. Remember, this is very important. It should reach at the same vertical level at which it is launched. So for example, if you have a projectile which is thrown horizontally, which will go down only, say particle projected horizontally from the terrace of a building, then particle will always go down from its initial level, and therefore the concept of range will not come for that projectile. So this is my projectile equation. When we can modify this, when the particle covers the range, then its vertical position becomes 0 once again. So we can put that in the equation, do some moving around, and we get equation for r very quickly. R as v0 square sine 2 alpha 0 by g. So this is the equation for the range of a projectile. Let's see on what factors the range depends on. One can easily see the range is proportional to the square of the initial velocity. That's very obvious. If you throw harder, farther it will go. If you throw slower, it will fall nearby. So the range depends on the initial velocity. Range is inversely proportional to the acceleration due to gravity. That is also obvious. If the gravity pulls harder, the particle will fall quickly. If the gravity is weak, the range will be longer. Unfortunately, on Earth surface, the variation due to gravity is too little to witness this phenomena. If you throw a projectile on the moon surface, since the gravity is less there, projected at same angle and same velocity, it will travel a larger distance. R is proportional to the angle of projection also, in a way that R is proportional to sine 2 alpha 0. R will become maximum if sine 2 alpha 0 becomes maximum, or the maximum value of any sine function is 1. That means R will be maximum for 2 alpha 0 to be 90 degree, that is for alpha 0 to be equal to 45 degree. So that means if the particle is projected at an angle of 45 degree, it will get some maximum range. So let's try to understand this. If we throw a projectile with the same speed but at different angles, then it travels different ranges. As the angle increases, initially the range increases, but as the angle goes beyond 45, the range starts decreasing once again. So you get your maximum range for an angle of projection at 45 degree. What about the height of projectile? Very simple to find out. This is the vertical velocity equation. At the highest point, the vertical velocity will become 0, and therefore Vy is equal to 0 at y is equal to h. We can put this in this equation and do some moving around. We get h is equal to v0 square sine square alpha upon 2g. So what factor does it depend on? Again, you can see it is inversely proportional to gravity. Gravity is stronger, less height it will achieve. It is proportional to v0 square. So projected with higher speed, it will go much higher. In fact, it's proportional to v0 square. That means if you double the speed of the projection, the height will increase 4 times, and it's proportional to sine alpha 0. That becomes maximum for alpha 0 equal to 90. So if a particle is projected vertically up, it will go maximum height. Time of flight. Time of flight is time taken to complete the range. So for the vertical motion, we know that the y is equal to v0 yt minus half gt square. For completing the range, y is equal to 0 and small t can be written as capital T, time of flight, and therefore v0 yt is equal to half gt square, and that gives us t straight away, 2v0 sine alpha 0 by g. This time is the time taken for the particle to go up all the way to maximum height and come down. If there is no air resistance, then the time to go up is same as time to come down. The time to go up is normally referred as time of ascent, which is half of the time of flight. So this 2 will go from here, and this is called time of ascent, TA. So let's take some exercises to understand these concepts quickly. A block slides on a frictionless inclined plane surface which ends in the curve at the bottom. As the block leaves the surface, it is projected in the air as a projectile. Find the direction of its acceleration at points A, B, C, D, E and F. So you can see here that there's a slide on which a block is projected. The block goes down all the way. But when it reaches here, it will have a very high speed. So with this speed, it will start moving up. As it reaches here, the surface ends, and then it becomes airborne, it becomes a projectile. We have to find out direction of its acceleration at all the points. So if you want to solve the problem on your own, do solve it, pause the video, solve the problem, come back and check the solution. So here is the solution of the problem. So let's say that with red vector we draw the acceleration and a dotted line shows the normal to the surface. So what happens at the point A now? So at the point A, you can see that the surface is this way. So normal drawn to the surface will go in this direction. And you can see that the body is sliding in this. It's a flat surface, not a curved surface. And the body is sliding on a flat surface. Speed will go on increasing in this direction. And therefore, the direction of the motion is fixed. And therefore, the acceleration vector will point in this direction. So this is my acceleration vector and this is my normal vector. When you come to the point C, what will happen? What will be the two directions? So you can see that the normal is here. Now the motion is along the curved path. As we have seen in our previous videos, if the motion is on a curved path, then the acceleration vector point inwards. Since the body is still going down, its speed is increasing, and therefore its acceleration vector will be pointing somewhere in this direction. At the lowest point, the velocity hits a maxima, and therefore the acceleration vector is working in the direction of the normal. As you go to point E, the velocity is decreasing now, so the acceleration vector will be in this direction. So that's the normal and the acceleration vector. But what happens at point F when the body gets airborne? So you can see that when the body is airborne, the only acceleration now it is experiencing is acceleration due to gravity. So both for point F and point G, the acceleration is only acceleration due to gravity, and it works in the downward direction. Let's take another example. A football is kicked at a speed of 30 meters per second at an angle of 30 degrees with the horizontal. What is the maximum height and range that it will achieve? Will it make through the goal post, which is 70 meters away and 7.32 meters high? So if you want to solve the problem on your own, do solve it. Come back and check the solution. Here goes the solution. Let's write down what is given. Alpha 0 is 30. V0 is 10 meters per second. So initial constants of the motion. We know height equation. We can substitute the values, solve it. The maximum height that the football will achieve is 11.5 meters. We know the range equation, V0 square sine 2 alpha 0 by G. Put the values, solve it. We get the maximum range as 79.5 meter. What will be the height of the football at the position of the goal post? So for this we can use trajectory equation. In this equation, in place the position of goal post at 70 meter, that we can put rest of the things, solve it, and we get height of the football as 4.8 meter. So at 70 meter distance, the height of the football is 4.8 meter, while the goal post is 7.32 meter high, which is much higher than the vertical position of the ball, and therefore ball can enter the goal post. So let's take another example, horizontal projection. You will see that here the concept of range will not apply. A ball is thrown horizontally from the top edge of a 100-meter tall building with a speed of 10 meter per second. Find the ball's position, distance from the edge, and its velocity at the end of 1 second. I would strongly recommend that you solve the problem on your own, then come back and check the solution. Here goes the solution. Here is a rough sketch of the problem. A building, a ball projected horizontally. We can take the point of projection as the origin, draw our x horizontal and vertical axis. Time t is equal to 0 is the moment when the ball was projected. It was projected with the horizontal velocity of 10 meter per second. Since the ball is projected horizontally, its angle with the horizontal axis, that is alpha 0, is 0. So these are the two constants of the motion, v0x and alpha 0. We have to find at time t is equal to 2 seconds, what is the position xy and what is the velocity. The horizontal position at t is equal to 1 second. Now x is equal to v0x into t. You put t as 1, you get it as 10 meter. Vertical position at t is equal to 1 second. We can use vertical displacement equation. Y is equal to v0 yt minus 1 by 2 gt square. The ball is projected only with the horizontal velocity. So at the time t is equal to 0, the vertical component of the velocity will become 0, and therefore this term will become 0. You put the values and you get it as minus 4.9 meter. So at the end of 1 second, your x position is 10 meter and your y position is minus 4.9 meter. So as you can see, the ball has moved to the right, that is towards the positive side of the x-axis, while the ball has moved down, that is towards the negative side of the y-axis. The distance of the ball from the origin can be obtained by the distance formula. You put the values, it will be 11.1 meter. So what is the velocity at t is equal to 1 second? As we have discussed earlier, the x component of the velocity remains unchanged. Therefore, Vx is equal to V0x, which is 10 meter per second. Vertical component of the velocity will go on increasing, and it will be given by the formula Vy is equal to V0y minus gt. Remember, V0y is 0, so it will be minus gt. You put the values, you get it as minus 9.8 meter per second. Initially, the vertical component of velocity was 0. After 1 second, ball has gained velocity in vertical direction, and it is now minus 9.8 meter per second. The velocity vector can be written as 10 I cap minus 9.8 j cap. Velocity magnitude can be obtained by using Pythagoras theorem, 14 meter per second. Angle that the velocity vector will make at this moment with the x-axis is obtained by tan alpha. Alpha is tan inverse minus 0.98, which is minus 44.4 degrees. The minus sign shows angle is in clockwise sense. Let's take our last example for the day, a projection below the horizontal level. A ball is thrown at an angle 30 degrees below the horizontal level from the window 10 meter above the ground with an initial speed of 10 meter per second. How far horizontally from the window the ball will land on the ground? The acceleration due to gravity is 10 meter per second. You can ignore air resistance. So again, try to solve this problem on your own by pausing the video. Come back and check the solution. Here goes the solution. Here is our rough sketch and the data which is given to us. The point on the window from where the ball has been thrown can be taken as the origin, and from there we can draw our x and y axis. The ball is projected with an initial velocity of 10 meter per second at an angle of 30 degree from the horizontal. This angle of 30 degree is measured in a clockwise sense from the x-axis, and therefore it will be considered negative. The ball goes in a parabolic path and hits the ground. You have to find out how far from the window it will land on the ground. The y component of initial velocity is v0y v0 sine alpha 0, which can be calculated as minus 5 meter per second. The y displacement can be obtained by substituting the value in displacement formula. That will be a quadratic. You can solve the quadratic to get the two answers, t is equal to 1 or t is equal to minus 2 seconds. You can ignore the negative time. You can use t is equal to 1 in y equation. So therefore, how much time ball takes to reach the ground? It takes 1 second. In that 1 second, how much horizontal distance will it cover? So the x component of initial velocity is v0 cos alpha 0, which if you calculate will be 8.66 meter per second. Therefore, the horizontal distance traveled is v0xt, which is 8.66 meter in 1 second. So in 1 second, vertically it will drop by 10 meter, horizontally it will travel a distance of 8.66 meter. Here are some of the review questions to deepen your understanding in the subject. There are activity problems. You can try to solve them on your own and then check the answers. Thank you.